Attendees are in listen-only mode.
Okay. Good morning or good afternoon, everyone. This is Alan Schimmel, Editor-in-Chief at DevOps.com. Thanks for joining us today for another webinar. Today's webinar is sponsored by CloudBees. We're going to just get started here in about a minute or so. We're waiting for late arrivals to join us. But until we do, I wanted to take a moment to go over the GoToWebinar control panel with you. Hopefully, you're seeing the control panel in the right-hand corner of your screen. There's only a couple elements of the control panel that I think will be important to you. The first one being the question section of the control panel. And if you hit the caret next to the word questions, it'll pop open. The idea behind this is we have set aside time for questions at the end of today's webinar, but rather than waiting until then to ask, you can type your questions in there and we will have them in chronological order and try to get to as many of them as possible at today's webinar. If you can't see your control panel, as someone has just asked, if the great segue to the next part, which is the chat section, chat window down at the bottom. At the bottom, there is a chat window, and you can, through that, chat with, you can chat with our backstage webinar engineers who can help you with that. Of course, if you're not seeing the control panel, you may not see the chat session either. If you're using a computer to connect to this, I'm not sure why you wouldn't see the control panel at all. Maybe it's somewhere else on your screen, or perhaps you've minimized it, but it should be there. With that being said, we're already 2 minutes past the hour, and I don't want to take away time from what should be a great presentation today. Today's webinar is Continuous Delivery with Jenkins Workflow and Docker Explained. And we're happy to have and glad to have Neil Hudson, Principal Solution Architect of CloudBees, joining us today. Hi, Neil. How are you?
Hi, Alan. I'm great. Thanks for having us.
Great. Neil, I'm going to turn it over to you because I know you have a lot to tell our audience, and I'm sure they can't wait to hear it.
Certainly. Thank you. And I just want to take a quick opportunity to thank you, Alan, and DevOps.com for having us. And I want to thank everybody for attending today. So as Alan mentioned, we are going to have plenty of time for questions at the end. So we'll be taking your questions as I go along, and I'll be answering those at the end of today's session. So without further ado, let's get started with the slide deck. Okay. So first about me, my name is Neil Hudson, of course. I'm working for CloudBees as a solution architect. So I took a various different path in my career. Like many of us, we start out doing some different things. I was actually in the high-frequency trading world. So in that world, I was acting as a technologist and analyst. So I worked with a lot of different code bases, and all that was obviously very contingent on making money, right, for the trading firms and for yourself. And so code itself was actually tested for the most part using some very rudimentary tools, and most of the time you really didn't know if it was working until it was in production. It was actually trading real money, live dollars were being floating around. So with that, I decided to grow up a little bit, and I joined the ranks with Red Hat. I worked with Red Hat for a number of years, talking about cloud solutions and DevOps technology, and of course Linux technologies. And so now I'm with CloudBees, and I wanted to kind of share with you a quick slide about CloudBees, who we are, our goal, and our business value. So we aim to be the #1 continuous delivery solution out in the marketplace, and as it stands today, as you all are well aware probably, Jenkins is the #1 CI tool in the marketplace as measured by active subscriptions. So now you get a chance to understand who I am and who CloudBees is. I'd like to actually have a little bit of interaction with our audience. So with that, I'd like to hand it back over to the DevOps.com team, and they're going to actually have a poll for everybody to answer here.
Great. Thanks, Neil. Jules, if we can have the poll question up. Guys, really simple question. If we can have your answers, we will get it right back over. So our quick poll today is select each of the following that you're currently using, and obviously you can pick more than one. Jenkins Docker and/or automated deployment. Hopefully it's not too hard a question and we can have your answers in a few seconds. You can start answering right now, and we will cut it off in 5, 4, 3, 2, 1. And the answers are, well, no surprises, or maybe surprises. Neil, I don't know if this is what you were expecting, but certainly the overwhelming majority of our audience is using Jenkins, 90%, pretty high. But you know what? 41% are using Docker, and that's fairly high for audiences that we've seen. So I guess we have a very Docker-savvy audience, and over half of you are doing automated deployment, and that's encouraging to hear as well. Neil, I don't know if you think that's a surprise or not.
I think I am pleasantly surprised with those results, Alan. I think it's an overwhelming majority that are using Jenkins, and certainly lots of people are looking at Docker, and with automated deployment numbers above 50%. That's very good. So I will try and tailor the conversation as we go towards the audience. So I think we still have time for one more poll question, right?
Sure. Okay, and next question. And guys, rather than putting your answers in the question section of the control panel, if you can click on the answers out on the screen, it'll help us get that tabulated. But my organization is select one of the following: doing full continuous delivery, doing automated continuous integration, scripting builds and pretty happy with the process, using many manual process, but nothing breaks too often. And again, this is just select one of these if possible, and we'll give you a few seconds here to do that, and we'll go from there. So we'll give you 5 more seconds. 5, 4, 3, 2, 1. And survey says, wow. So just 11% consider themselves doing full continuous delivery, Neil. That's a little lower than I probably would have thought. 57%, overwhelming majority here, do automated continuous integration. That's good to hear. 16%, again, relatively low, are scripting builds and are happy with the process. I wonder how many are scripting builds and are unhappy with the process. And then another 16% are using many manual processes, but nothing breaks too often. And that's probably in line. What do you think, Neil?
Well, I think this poll was really designed so everybody gets an idea of what their colleagues and friends are up to. When it comes to delivering software, I think continuous integration, the second option there, is actually hard. Our Jez Humble is very famous for saying that the continuous integration, having a full regression test system, isn't very easy to pull off. So I think with the majority of people doing that, that's excellent. And then doing full continuous delivery, I did expect a small number of people there, so nothing to worry about that. But then, so certainly, a lot of people are doing some automation out there. That's what this tells us. So that's good stuff.
Absolutely. Yep. Okay. I believe that's the end of our polling questions. So let's see if we can return, Neil, to your presentation here.
Definitely.
All righty.
All right, so that brings us to back to the slide presentation here. So, this is a quote that became first offered by Mark Andreessen. So he said, software is eating the world. I think a lot of us can agree with that. If there's a term that's floated out there right now, everybody's focused on the micro moment. So, whether you're in your car or you're looking at your phone at a stoplight, or you're in a meeting and you're glancing down at your smartwatch. Really application and delivery of information and communication is all about instantaneous feedback, and the Internet of Things is becoming very true with everything having an IP address and being able to communicate back and forth. So with all of that, many of you that are in the audience today, you certainly can appreciate that you're being tasked with doing more things and delivering it, sooner and faster. I just wanted to kind of show actually something that you may not all be familiar with. It's the cockpit of the A380. So this is the large Airbus super jumbo airplane. And so right away you can see that this cockpit isn't like the old style we're used to seeing in textbooks with the manual pulleys and cables. And so this is all fly-by-wire. So there's certainly a lot of software here, and I'm sure there's plenty of redundancy there as well. But so you can appreciate that the software that's running this plane certainly has been tested, and it's overwhelmingly software is definitely taking over there. So, and then we kind of contrast that with what we're used to seeing in terms of driving our car, whether we're commuting back and forth to our workplace. Here is the model Tesla, the Tesla Model S. So this provides essentially a view into the cockpit there. So you can see that there's a large screen in the center console with all kinds of driver feedback. All of your controls and everything are fully presented there with via software. So if you're lucky enough to have one of these cars, I don't, but if you're lucky enough, you know that these updates come over the airwaves, and so you can appreciate that that's certainly something that has to be made sure to work before it's sent out. So I wanted to kind of set the context for what we're going to talk about here. So software definitely helps you achieve your goals. Many of you have lots of business needs, lines of business that are asking you to do and present lots of things throughout your workday. So many of you could probably find reasons for doing your job in this slide, depending on what various angles that you're in. But the fact is that we're all pressured to deliver software faster. And so that then let's talk about this question: how would you deliver better software faster? And it's all about taking that code change from development and moving it through some kind of testing system, some kind of pipeline, if you will, on its way to the production side. So there's a great concept out there. It's called DevOps, and I think Gartner just mentioned it recently that DevOps itself as a term has hit its it's basically saturated the market in terms of its hype. But I think that the takeaway here that, as you can see in this quote here, is that DevOps, really bringing your developers and your operations staff together, is really all about communication and collaboration. So it's not just necessarily the tool set as it is the people and the process that you're actually up to. It's actually getting the ability to kind of move things faster, but then also have communication, have feedback loops, and make continuous improvement as you go along. So then as you're basically building your software processes and testing that code, you can see that automation has to be the key. You can't rely on the manual processes. As many of you noted, many of you are not doing manual scripting for your build processes, so that's awesome. But as you view this picture here of the model Tesla factory, you can see it's all fully automated. There's all robots here. So essentially, all the software that gets put into these robots is ensuring that your end product is reproducible and stable, no matter how many cars there are being built here. So continuous delivery as it applies to IT, you're looking at essentially having a pipeline that moves code from development on the left, all the way to production on the right. And so at every phase, whether it be commit or test, you ought to have a feedback loop. Because the business is certainly interested in finding out, where the new features are in the process. They'd like to know that, things are going to be delivered on time. And so the the factory floor that you see is what we model our pipeline with. So next, let's actually talk about continuous delivery, because you need to have the ability to actually manage your automation engine. So as soon as a code change gets committed, that's going to trigger some kind of source code management system to send a webhook out to a tool, and that ideally is then going to set up your process of doing continuous integration, eventually continuous delivery, and then you need a tool to orchestrate all that. You need a tool to kind of get the results as they're being generated for each stage. It's helpful to have a tool that kind of manages that and can continue that no matter how many developers you have on staff or how many jobs you're looking to run or applications you're looking to serve. So then that leads us into Jenkins. And so, as the title of this whole presentation shows, we're here to talk about Jenkins. And so as Jenkins we'd like to think of that as the hub of the DevOps ecosystem. And so you can see here that now Jenkins is in the orchestration seat. It's got basically insight into all the different phases in your pipeline. So as you move from the code and commit side on the left over to the deploy side, you see lots of integration points that are available to Jenkins. So many of these are potentially, stack tools that have some, they've been around for a while. So they're somewhat legacy, and some of the, newer kind of tooling that you see here in this, this slide kind of points to where we can go in the future. So currently, 1,000 different plugins that Jenkins is involved with. Upwards of 100 of those are actually DevOps tools. You can actually use those as part of your CD pipeline process. All right, so now we're actually going to talk about app deployment. And for those that have automated their app deployment, it's kind of rife with potential issues. So if you think you've actually fully automated your deployment, let's take a look at this scenario. So in this scenario, you've got 4 different environments, of course, from dev to QA to staging to prod. And we look at our application code that typically is being tested, right, in each of these different environments. But unfortunately, as it gets to production, what could potentially happen? Well, many different things could happen, right? What worked in dev is not working in prod, and of course the famous last words are, well, this code worked in dev, I don't know what happened on the way. So a lot of things can happen, right? And in terms of this, we're actually kind of concerned with the operating system configuration. So the actual infrastructure configuration that you see along the bottom of this slide, it points to the fact that, that environment could definitely get unstable in this process. One environment might be linked to another group for some work, and they might install some tools that you weren't aware of, right? We all run into that, I think. So how do you deliver consistent operating system configurations as you move, throughout your process from dev to prod? It's a matter of taking and basically stamping your application code and your operating system configuration. So a way that we like to do that, of course, one of the most popular ways to do that, of course, is with Linux containers. And of course, the company behind that, most of us know today, is Docker. So Linux containers, as we all know, have been around for a long time. They, basically the premise is excellent. It's a small footprint. It's easy to configure. It provides for a very portable content manager. So essentially, you can package your application code, get all your binaries and all your third-party needs, put it into a Linux container, and then also have your own with that as well. So now you have one harmonious package. As you can see here, now we've got everything inside of a Linux container, in this case Docker. Now we actually have our application code and our OS config all housed together. All right, so talking about Docker for a little while here, the question might be, so how am I going to build a Docker image? Well, certainly, in a Linux, Unix mindset, you can certainly sit down at your keyboard and you can start typing away CLI commands to get your Docker images built. Of course, building by hand, that kind of defeats the purpose of automating anything, right? So if images need the same type of automation, we ought to look for a way of housing that instruction. So for those of you familiar with Docker, the Docker file essentially creates that set of build instructions that you need to assemble that Docker image. So all of the things that you need to keep your application and your OS content together is housed in the Docker file. So this instruction set has all kinds of different parameters that you can set, ways of installing tools, ways of adding different files or directories to the image. So Docker file is what we use. It's essentially our blueprint way of keeping everything versioned. And now we're going to move into how Jenkins and Docker work together. So Jenkins essentially has 6 different plugins. These were actually released last summer. These plugins allow you to do things within Jenkins that interface with Docker, and we seek to allow you to make those changes within your jobs that you create today. And then that leads us into, well, what's the vehicle in which we're going to do that? So if you're continuously building and delivering Docker images and Dockerizing apps, we like to think that you can use the Jenkins pipeline plugin. So I'm actually going to pause here for a moment because many of you are familiar with the Jenkins Workflow plugin. So we actually went through a rebranding. So we're actually changing what most of you refer to as Jenkins Workflow. By name only, we're changing it to Jenkins Pipeline. So essentially, for those of you that go out eventually and install Workflow, or if you haven't already, we're actually going to change the Workflow Aggregator plugin by name only to the Pipeline plugin. So I'll be referring to this plugin, hopefully, from now on as the Pipeline plugin as we go along. What I'm showing actually here is actually the stage view. So this is actually a nice visual representation of that Pipeline plugin. So along the rows, so for each row here, you can see we've actually got an iteration of this pipeline job that was run. So you can see we've got our phases there, which are actually known as stages. So we've got 7 different stages that are the columns you see, and those are all named, of course, to kind of represent the process of your pipeline from left to right. So we're doing everything in this actual pipeline job from building the app, and that could be a simple Maven, type process where you actually compile your Java code and create a WAR. Once that's set, you can do, the next stage would come in where you're doing a sonar analysis, and then it continues from there. So the nice thing with the stage view is that you can see, visually how long it took each stage to complete. If you do have a bottleneck, you'll see that right away based on the time aggregate that it took to complete that stage. And then, of course, we've got that second row there that's red, so that indicated that we did have a problem towards the end there at that last stage where we're publishing a Docker image. If you are using the stage view with the pipeline plugin, you can actually hover your mouse over these little squares, and you'll get more information about what was wrong with that particular iteration. You can do many different things with this pipeline plugin, and we'll get to more of that as we get on. So it wouldn't be fair to talk about Jenkins Pipeline without talking about the other plugins that provide you a means of doing essentially a workflow, as it used to be called, within Jenkins. So there's other plugins that many of you are probably familiar with, things that come to mind like the Job DSL plugin or Build Flow, and you probably recognize some of those that output here. Basically, essentially Jenkins Pipeline is meant to cooperate with all of those plugins. But in a sense, I wanted to kind of just talk a little bit about the solutions that are out there besides Pipeline. It can become somewhat painful in order to use those other plugins when you're trying to design your pipeline. And what I mean by that is when you have several jobs with those other plugins, you are typically chaining them together. So as you do want to make changes to that entire pipeline, you're worried about, sharing variables and state between jobs. How are you going to manage that? You've got upstream and downstream configurations that you have to be interested in, and it may perhaps limit your logic. So I'd just like to interest you all in the Jenkins pipeline because, in a sense, it allows you to do everything from a simple to a complex workflow inside of that pipeline plugin, and it essentially allows you to do interesting things like restarting the pipeline. Whether you are restarting that from the UI, you can actually do many different things because it's all represented as Groovy code. So to say it another way, Jenkins Pipeline is defined itself by a Groovy DSL. So for those of you who don't know, Groovy evolved from Java, so it's got a fairly quick learning curve if you're totally new to it. We do have there's tools within Jenkins to help you learn how to use Jenkins Pipeline. We've got snippet generators, so you can actually learn how to create sample steps while you get your learning process on. So again, lots of different features with the Jenkins Pipeline, and we'll talk about those a little bit as we get into how Jenkins Pipeline works with Docker. But I do want to kind of the checkmark items here, things like branching and looping, creating checkpoints so you can actually restart from a certain part of your pipeline. Those features I think are pretty compelling when it comes to Jenkins Pipeline. I also wanted to point out the ability to do manual input, as you can see there, so you can actually pause your pipeline so that you may want someone to actually come in and physically take a look at the process, pause the automation, perhaps let someone else, a manager per se, get an email notification and approve it before it actually gets to production. And then, of course, the last check mark item here is parallelization. So as you can see there in this graphic, you've got a perf test, a selenium test, and a sonar test all running in parallel. So that does allow you then to have multiple tasks running all at the same time in this one job. Once all of those complete successfully, it will move on to the next stage. So, all right. So when we're talking about Jenkins pipeline and how it works with Docker, the great news is that the pipeline actually has several Docker features that you can use within it. Whether you're using the UI or whether you're using the pipeline definition with Groovy, we do have keywords that help you use Docker and all of its other features. So essentially, as you can see here, we seek to have essentially a semblance of how the pipeline and the Docker images work together, with the intent that towards the end of this pipeline, you can have basically a gold Docker image, as it might be, used with the OS config also. So that instruction set is always important, and it's all represented potentially as a Docker file if you like, or as a Docker image itself. So I'd like to actually spend a little bit of time talking about some areas that Jenkins works with Docker images. And so we're going to talk about 3 different topics here. So we've got the build and publish topic, which allows you to essentially take a Docker file and push the resultant image up to Docker Hub. We'll talk about Docker traceability. So you certainly want to be able to identify what particular build, what job build actually pushed a particular container out into your potentially the production world, or perhaps where it went after it left Jenkins. And then we're also going to talk about the Docker Hub notification. So you'll be able to have Jenkins be triggered essentially if a tag container is pushed to Docker Hub. So let's talk about build and publish first. So essentially you want to basically have here an example pipeline using build and publish. So we have a graphic here that shows you first, let's say with this pipeline, you're essentially going to have ability to build and test your app. So you're going to do a source code management system checkout. Let's say this is a Java application, so we'll do a Maven package, and we'll archive the war. So now we have our war essentially out there. Now we're going to basically build and publish our Docker image. So we'll retrieve the war. We'll go ahead and we'll do a Docker build. We'll tag that Docker image so we have that for version control later on. And we'll do a Docker push. So now we have that image saved. We're going to go ahead and test that image. So we'll deploy that image out. We'll do a Docker pull. We'll actually register that event, run that Docker in a container, and then essentially test that image. So that's essentially this pipeline that we're going to use within the build and publish realm. So step 1 with build and publish, and we're going to actually show you essentially some graphics here. These are actually taken right from Jenkins, so it gives you an idea of what we're talking about. So from the UI perspective here, we've got a post-build action within a Jenkins definition of the job. We're going to actually archive the artifacts. And then once that job was run, you can see the resultant artifacts are there. So here's the permalinks that many of you are probably used to seeing in Jenkins. Both the Docker file and the actual jar itself are both represented there for you to access. And those artifacts are now the published artifacts. Okay, step 2. We're going to essentially build the Docker image now. So we're going to retrieve the artifacts that we need as input. We're going to need the jar and the Docker file. And then we're going to invoke the Docker utilities to essentially build the image, tag it, and publish it. So let's go out. We're going to obtain the artifacts. We're going to do that by actually copying artifacts from another project. So this is a screen capture right from Jenkins using the copy artifact area feature. And so we actually can see here what we're actually using an upstream project in which to copy the artifacts from. And we're actually listing the artifacts that we're going to be using. So a little bit of regex there to get the jar and the Docker file. And now once that's complete, here's our Docker file. So here's our instruction set. So you can see we've got the information in there in terms of what image we want, how the volume is going to be mapped, the actual jar itself, and how the entry point is going to look. So now we'll move over. We're actually going to invoke Docker. So we're going to use our Docker build and publish area, indicating essentially we're going to identify the image. So we actually put our image in that we want to keep. That's what we're going to essentially use when we publish that out later. We're going to bind with the Docker host that we need. So we actually have a point here in which we can actually insert the Docker host URI. And then, of course, most of you that are used to using Jenkins, you're familiar with ability to have server credentials. So here we actually have some server credentials around the Docker keys that we're going to use. We're going to bind to the Docker registry itself using our registry credentials. And then once that job is complete, we move over and look at our Docker Hub public repository, and here's our tagged version. So that essentially is the build and publish. That's an example of what that would look like from the UI side. Next, I want to talk about the second topic, around Docker is traceability. So, of course, for those that are, doing development, and you always get pinged later for the audit trail. People want to know where those artifacts went, how they got there. Traceability is an interesting key point because you are concerned about, okay, now I've got an application instruction set. I want to basically control where and when these things get pushed out. So with traceability, we're essentially going to basically use this in terms of using the Jenkins artifact that's already out there. We're going to build upon that. We're going to track the creation and use of Docker containers. We're actually going to use the artifact fingerprinting for a lot of this that you probably, so some of you are already used to using artifact fingerprinting. It's basically been harnessed here to use traceability around Docker. And then each build will be able to show you the fingerprints created icon. So essentially you've got here a screenshot of Jenkins, and here you've got the fingerprints themselves that were used during an actual job that was run during the create and publish stage. So there you've got the image fingerprints, so we've got the links there to actually help us move right to the traceability view. So if you were to click on those, you'd actually get to the Docker traceability view here. And then you can actually take a look at all the containers that are registered out there. So I've got a container highlighted here. This one's actually stopped, but then towards the higher up, you can see some of these actually deployed. So that gives you your traceability view, the ability to check and see where things are actually deployed. If you were to click actually further on that container, it's got a lot more information in terms of what's going on with the usage. You've got the raw data that's there in JSON format. You've got the events that were recorded by Jenkins and that are down here towards the bottom. We've also got a link here to the build itself. So then let's see this in action. So in terms of traceability, many of you are probably familiar with this age-old issue where you're running tests and there's a problem and you need to fix it, right? So that's what you typically get measured in, is time to fix as you're, because everybody wants to be able to write code. They don't want to have to spend a lot of time tracking down the actual logs, find where the actual source of that, bug might be. So we actually have a logical sequence that we're going to actually use, and we'll showcase that with the following slides that are going to come. So essentially you've got 5 different steps here. In this logical sequence, you're going to basically check your running container. From that, you're going to link yourself to the image, get to the actual job that built that image, check the application version, the build, and then the source. So I'll show you that in a series of images here from container to image build. So first, we're going to actually go find our link to our image build, click on that, and you get to the actual image build iteration. So you see the build number there. You see the fingerprints that are available there on that little side panel. Click that See Fingerprints, and then you're going to see the builds that provided the artifacts here. Once you click on that, there we are. We're right back to our build artifacts, and we can also even see if there were any changes or what changes those were. So we can see who started that. There were no changes. And then you can see that the source code management system commit, the revision number is there as well. So that's traceability in action. That gives you an idea into how this would be available to you and your teams. I want to talk about the third issue now with Docker, and it's the notification area. So anytime you might potentially be using, let's say a Docker Hub, whether it's a Docker Hub that you house, with the free version or enterprise version, or perhaps you have an on-premise version, it'd be nice to actually have Jenkins automatically be triggered in case, you've got a container that's pushed to the Docker Hub. So let's take a look at this in more detail. So what are the steps in order to set up your Docker Hub notification? Well, there's actually 3 steps. First, you want to go to your Docker Hub setup, and you're going to set up a webhook account for notification. And then you're going to set up your Docker registry to make callbacks on image events. And then you're going to make changes to your builds in Jenkins itself. So let's talk about those 3 steps. So first, we're going to go to our actual Docker registry. There's an area here where you can actually add your URL for your webhook, give it a name, and then the actual URL to your Jenkins. Once that's all set up, then we actually go to our job in Jenkins. We can edit it, and you can see there we've got a little radio button that signifies that we're going to monitor Docker Hub for image changes. And then you've got a few other options in terms of how you want to manage that trigger and what the behavior you'd like for that how you'd like that to go. Okay, so there's the 3 areas of Docker. Let's take a look at this from a full pipeline point of view. Essentially, if you're considering using Docker and Jenkins, let's take a look at a full pipeline, right? From all the way from, let's say we've got our 7 phases here, from build and unit test all the way down to publishing a Docker image. So we're going to talk a little bit about how you'd actually define that and what that might look like in terms of Jenkins and the pipeline Groovy. So we're going to take a look at a pipeline Groovy example here, and we're going to build the app just like we do today. We're going to compile and test. We're going to basically produce a WAR. We're going to do a Maven package and a Maven verify. And then we're going to basically see what the difference is, and we'll prepare the release for basically version control. We'll actually spin up a container, test that Docker image itself. Perhaps you want to run some kind of inspection on that, and then finally you can push that out to the registry. So we're going to get into some areas here once we take a look at our Docker template. So first, a note about Docker slaves. You can actually specify the image as a template here, and so you can actually define Docker as the actual build area for this build itself. So this is just a quick way to show you how you create the Docker template for your Docker slave, and then you can run your Groovy pipeline code utilizing that. You can also assign it a label. A good label to use would be Docker, to signify that this is in fact a Docker slave where you're going to run your actual Jenkins pipeline. And so now we're going to actually test the app, and we're going to actually get into the code itself. So here we are. We've got a little snippet of Groovy. Essentially, we're going to first take a look at this code, and we'll start at the top here. So we certainly, when it comes to Groovy, you indicate the node that you need. So here we're going to use the node Docker that you see there on the first line. We're actually going to use the Docker keywords here within Groovy. So you see docker.image. So that will then allow you to take an image, spin it up as a container, and that's where your build's going to run. So everything inside of the actual code block here is going to run within that particular image itself. Next, we move on to this second stage from our pipeline. So this one's the sonar test area. Here we're actually going to be doing some API tests. So in this next stage, we're going to be doing things. So you can see there we've got a shell command with the sh indicator keyword. So we're actually going to run a batch shell here. We're actually going to do a Maven verify. And then we're also going to use our JUnit result archiver. We've wrapped that class so that we can actually see our results themselves from this particular API test. All right, so now we're actually going to focus on the image creation and the use and checking of that. So let's take a look at the Groovy code for that. So basically we need to ensure that we have a Docker host first. So we're going to bind to the Docker host, and you see we're using the docker.with server here in this case. We're essentially going to do a quick directory change into the Docker, into the correct directory. And then we're going to invoke the Docker image, the docker.build command. So that's actually going to take our Docker and we're going to actually incorporate the build version as well there, and we're actually going to create an object now that's going to house our Docker image. All right, so we're looking further down at this code in terms of the, managing the Docker image. So here you can see we're going to run our image now. So we've got our object, our Docker image object. We're going to invoke run against that. That's launching our container. We're going to do a quick curl here in order to submit the traceability report. So then you saw that earlier. That's how you actually can see, the audit trail in terms of how this Docker image gets used. Here's we've got an area here where we can run some tests on that actual Docker image. Now let's assuming that all went correct, or we can move into our publish Docker image stage. And here we're actually going to use our credentials. We're going to bind to the registry. Once that's successful, we can do a push. So we can actually push our image up to that Docker repository point. And then taking a look at Docker Hub, we can now see that our tagged version is saved there. So same result, both from the Docker, from the UI within Jenkins, creating a job that way, and then also using basically a Jenkins pipeline, which we've just shown you here with the actual Groovy DSL code, and using the Docker keyword and some of the other keywords that are available with Groovy. All right, so essentially in conclusion, I just want to bring us back to this Jenkins pipeline image. We definitely encourage you to use it. We here at CloudBees are putting an awful lot of engineering effort behind Jenkins pipeline. It's getting an awful lot of evolution. It's continuing to evolve and provide a lot more feedback. We're getting a lot of good adoption from the community, and we certainly hope that continues to continue from here. Again, Jenkins Workflow is now renamed to Jenkins Pipeline, but for most of you, that's all you have to remember. Getting the Jenkins Pipeline plugin is simple. You go out and find the meta plugin. It will install all of the dependencies that Jenkins Pipeline needs, and then you can go ahead and run your pipelines from there. And again, as I mentioned, there's ways to get started. If you look at the workflow type job, there's actually a workflow definition area where you can actually work on your Groovy code. You can see there's a snippet generator there, so you can learn how to use the sample steps. And further talking about Docker and CD and continuous delivery, we talked about ways in which to actually use both Jenkins and Jenkins Pipeline in order to get your Docker workflow, Docker pipelines actually working. So with these plugins, you can do several things with the Docker ecosystem, right? Working with the Docker file and your actual application. So you can maintain control of your actual operating system configuration and your actual application code itself. So how do we get started now? So I'd like to share this slide with you, and I'm told that you'll also get a copy of this soon as a follow-up. So here's some links to the documentation. Certainly the best place to start, I think, is with any of these tutorials or example source code. But certainly if you're curious about the actual Docker pipeline Groovy code that we use today, you can check this first link here. This link actually takes you through the whole work with Docker build and publish, with the traceability, and also the Docker Hub notification areas. So with that, I think we have some time remaining here, fortunately, for some good questions. I'd like to thank you for submitting your questions, and we'll get to the question and Q&A section here. I would like to open it up. My colleague Nigel Harneman has been actually perusing all the questions as they come in, and I'll allow Nigel now to come on. Nigel, how are the questions?
Yes, we've had quite a lot of questions coming in, so I've done a bit of a sift through some that I think will be widely relevant, but just to remind everyone that we will be following up with the questions via the Q&A on the post afterwards. So apologies if I don't get round to all of them. So a number of questions have come in, Neil, about the various plugins that you've talked about. So Workflow, now named Pipeline, and the Docker plugins, and a number of questions about whether those are available in open source versus the CloudBees version of Jenkins. So would you like to take that one?
Yeah, so that's a good question. Certainly, we get that question quite often. So essentially, the Docker pipelines were made available over the last summer, and those are in fact available as open source plugins. The Docker plugins here, the 6 that you see here, are all available as open source. So those are freely available. We as CloudBees with our customers certainly support those plugins. We intend to keep a key into the community and understand how people are using them.
And about the pipeline?
Yeah, great. So the pipeline, the actual Jenkins pipeline plugin, so that meta plugin with all of its dependency needs, that in itself is also open source. So we encourage you to go out there and use it. Everything, in fact, that we talked about today around pipeline, with a small subset of features are available as open source. The one that is a CloudBees feature would be the checkpointing.
Okay, good. Thank you on that. So a number of questions came in around publishing the Docker images to a repository, a registry. And so I think the example that you showed here was publishing to Docker Hub, the public Docker Hub registry. But a number of questions have come in around support for internal and private registries. Could you shed some light on that area?
Yeah, so Nigel, as one of my colleagues, I'll allow you to correct me if I'm wrong, but essentially the ability to enter in the field in terms of the repository itself allows you for a URI. So my understanding is that you can use essentially an enterprise Docker Hub, your own on-premise Docker Hub repository, as long as it follows the Docker Hub ways of running.
Sure. If you want to flick up to the screen with the syntax on, I can add a bit more to that. The syntax to do a push to a registry takes a number of parameters. One of those is the identity of the registry. I think in the example that you had, Neil, it was blank because that means by default it goes to the public Docker Hub.
Right.
If you want to publish to something internal, you can override that and put in your own value. So if you're using a repository such as Nexus or Artifactory that fully supports the Docker APIs, then you can publish to those internal registries that you may host within the firewall. One of the great things about the workflow and the plugins that you can use in the regular Jenkins jobs is they have a full integration with the credentials API, which means that if your registry is secured, which clearly if you're using the public one, it would be, to stop other people publishing on your behalf, you can nicely use the credentials API to store and handle the username and password that you need and pass that into the job step as it's running. So the answer is yes, you can use private registries and you can use them securely. Do you have anything else to add to that, Neil?
No, thank you, Nigel. Thank you.
That covers it, yeah. Okay. Let's have a look down some of the further questions. So there was a number of questions around using Docker with Windows. I guess we're not going to provide a huge amount on that other than that's down to the Windows ecosystem to support Docker. And I guess once that's there, we will be watching that and working out if we need to make any changes, but we can't answer for the Windows ecosystem per se. Let's have another look. So a couple of questions around pipeline and putting the pipeline configuration and the definition of it in with the application source code, so that as the pipeline changes over time, you can version it and know what version of the application used what version of the pipeline. Do you want to have a stab at answering that one, Neil? I think some of our new features around multi-branch and Jenkins file.
Yeah, so that's a great question, and so essentially the first thing that comes to mind with Jenkins pipeline is that, as a Groovy code, that can be stored actually in the job definition for the pipeline job. So there's an area there where you can actually type in your Groovy code, and there's a lot of enhancements around the editor. You can also actually version control the Groovy script itself, so you can actually store that in the source code management system. We tend to use Git quite often here, and so we show that as an example And then, yeah, Nigel, as you alluded to, we've got a lot of work here with pipeline as code, and that concept being able to essentially create an automated way of having Jenkins create, workflow jobs for your new projects that you have. So with the use of a marker file called a Jenkins file, and also with plugins that we've made available around multi-branch and organization scanning, you now have the ability to have a Jenkins file at the root of your code project. And so as that project comes online, let's say you add a new branch, if you add a new Jenkins file to that branch, Jenkins, if it's allowed to, can actually automatically create a workflow job for you based on that. So, a lot of people talk to, I'm sure Nigel, you get this as well, we get talked to a lot about, how do we manage all of these different projects within Jenkins? There's a lot of manual process having to stop what we're doing and creating a job for that. And then if the project gets deleted, we then have to go in and delete the job for that. Well, Jenkins can manage a lot of that. So.
Good, thank you, Neil. That's good. In fact, there's a number of other questions in that same area about managing code branches and things that came in while you were just about to start talking on it. So I'm hoping that has answered some of those questions, but we'll make sure that we follow up on those via the follow-up on the Q&A. So let's have a look at what other questions we've got. There's a number of questions came in about getting access to the examples that you've got. I think we covered off that they are in the Git repositories and things, and the links at the end of the presentation. Please feel free to download those and try them out. I think actually you've actually stolen my examples, so that's good. So I have confidence that they work. Anyone have any issues setting those up? Please feel free to reach out, and we will help with those. Okay, what else have we got? There's quite a lot of questions coming in still. Do you need a specific version of Jenkins to use pipeline? Yes. Pipeline came in, well, pipeline as it is now was workflow, came in 1.580. But if you want to make use of things like the Jenkins file, then really you need to be on the 1609 or perhaps even 1625 versions of open source Jenkins.
Right, which is the current release, the 1.625.
Yeah. Okay, let's have a look for some more questions. How much more time have we got? We've got a few more minutes, haven't we?
We've got another 8 minutes if we need.
Okay, so here's a question about test coverage and testing within the pipeline. So the unit test and Sonar analysis are run in Jenkins host or using a container. If using a container, we might need two different Docker files, one containing my testing dependencies and the other one with my production dependencies. I think in the example, Neil, you showed that the build steps for the basic application artifact creation were running inside a Docker slave. But I mean, my take on that is there's no need to do that. You can use any regular build slave for the earlier parts of the pipeline. You only need to use one with Docker for the Docker specific steps like creating the image and doing the publish. Do you agree with that?
I totally agree with that, Nigel. So yeah, totally, it's completely feasible for you to use, a normal Linux slave or build node in order to run, as Nigel, as you said, anything that's not Docker dependent. The Docker slave, in fact, is, apart from being ephemeral and getting a lot of advantages in terms of being able to spin up and spin down it, at will, would be for the Docker portion of that, right? So go ahead.
So I think in your regular freestyle job example that you showed, the job chaining means that you can run the first set of jobs on any regular slave, and it's only the ones that do the Docker build and Docker publish that we actually need to have, obviously, the Docker binaries there and running on a Docker compatible slaves. So I'm hoping that answers that question. So however you're building and testing the app today in terms of its running sonar analysis, you can do that today before you get to the Dockerization step, so that doesn't need to change. Another question that's come in, which hopefully these will be quite quick answers on. So, of course, one of the audience members said, are all the steps in the pipeline defined in the Jenkins file?
So if you are using a Jenkins file, yeah, essentially the Jenkins file has script and Groovy script within it that defines it.
So one of the things that we should also add about the pipeline plugin and the Groovy DSL is it does have the ability to download other library files from a source code repository and bootstrap into them, so you can have reusable functions held in a common Git repository or something that you can access. And we also have built within Jenkins our own internal what's called the CPS Global Library, which is again an internally Git-backed mechanism for you to have common reusable functions and definitions that you want to make use of within your pipeline flow scripts. So you may want to choose to have a standard way of doing a particular type of deployment, or how you run your particular build steps. You may want to package those up and make those reusable across a lot of the flows. So another question coming in, which is what is our support for some of the other Docker-related technologies like Kubernetes and Mesos?
Yeah, I mean, essentially, we do support Kubernetes and Mesos both in terms of your container orchestration and scheduling capabilities. We do have customers, right, that we're supporting today that are using Kubernetes. So we are working with both of those projects. You'll see a lot more of that further down the road in terms of our road mapping. Nigel, do you have anything else to add there?
We've also got support for Docker Swarm as well. So when you are setting up Docker slaves and defining them, I think it's almost a direct replacement that you can put in a Swarm host instead of a Docker host if you want to use Swarm. And again, if you kind of search around, if you hit Google and do look for Swarm and Docker and Jenkins and CloudBees, then hopefully the links will come to the top. So I know we've got a couple of previous articles that have been written on using Docker Swarm.
Yeah, that's great.
So Nigel and Neil, we only have time for maybe one more question, and then I think we're going to need to wrap up.
Okay, I've got one more theme of questions that have come in, and this is quite a high-level one. So a number of people have asked the question about how do we deal with in-situ upgrades of a running application, and a couple of people were asking about how would you deal with a deployment that fails and rollbacks. And so I guess I'm thinking here, Neil, you're going to add around doing perhaps blue-green type deployments, or having logic in the pipeline that can handle that sort of thing.
Yeah, so essentially, I'm not looking at the questions, but that comes to mind. So within Groovy, right, the DSL, you can do a lot of different logic steps. So you can do if-then statements, iterative looping, for loops, but you can also do have logic based on previous stages and success or failure of those. And there's plenty of examples that are being made available as well on the Jenkins Pipeline Wiki. So we have areas there that I think we'll include as well with the follow-up that comes back.
That's a good answer, Neil. And I mean, my take on that, just to add a bit more, and then I think we'll be wrapping up, is it's totally possible in the Groovy DSL, as Neil said, to spin up a container or do a deployment and then run some quick smoke tests against it. And then depending on the outcome, you can make a decision to either destroy that container or continue on with rolling out a further number. So you might go to 5%, go to 10%, and then carry on. There's also a mechanism where you can pause a pipeline script and ask for human input. So if you're monitoring your deployment, you may actually decide that you can't automatically test it, but you will pause, you will do some inspection, and if everything is okay, you will then push the button to continue down through the subsequent, ramp up of your rollout.
Excellent. Guys, I'm going to need to step in right here because we're just hard up on the top of the hour. Nigel, Neil, all of the folks at CloudBees, thank you so much for providing another great webinar here for DevOps.com and our audience. To the nearly 1,000 of you or thereabout who logged on at some point today, thank you very much for attending. It's hard to with that many people, it's hard to anticipate every need and want. But I think Nigel and Neil did a great job with the presentation. We do have all of the questions in writing, and we will get them over to Nigel and Neil, and we will perhaps try to get some of these in writing, and they will be posted along with the recording of today's webinar on DevOps.com and via CloudBees. And I think that's the best we can hope to do on that. So again, many thanks to CloudBees, Nigel and Neil for a great webinar today. Thank you all for attending. This is Alan Schimmel.